Okay, so yesterday we introduced our graphs of exponential functions, and today we're actually going to graph them. So this is the work, oops, let me flip back a page. This is the work we looked at yesterday, okay? So I'm using this, I'm gonna build something at the top of this page using all of these transformations that we saw, okay? So our exponential functions, y equals b to the x. Now we could have several different things that are added into this function. So we could have a coefficient out front. We can have a value added or subtracted to my exponent. And I can have a value added or subtracted outside of my exponent. And each of these things transform the graph in different ways. So first, our value out front, okay? That is something that will multiply our anchor point. And also, if it's negative, it's going to be an x-axis reflection. Okay, so that's one transformation that we saw yesterday. We also saw that if there was a negative here, then it would be a y-axis reflection. Okay. When we had a value being added or subtracted to within my exponent, it was a horizontal shift or a left-right shift. It's going to change the x value. And remember here, I'm just going to put opposite. Because it's x minus h, if it was 2, for example, plus 2, it'd be x minus negative 2, or we're going to move negative 2 or to the left. So it's always kind of the opposite of what we're thinking with that shift. If we add outside of our exponent value, that was the up, down, or vertical change, up, down, shift, where it's going to impact the y value. Okay. So this is how we're going to graph. And now these graphs are going to be much more of a sketch than anything else, because we're really only going to plot one point and then understand the shape and where the asymptote is for that graph. Okay, so here are my steps. So I'm going to walk us through the steps on this first one. First, determine if it's growth or decay. So we know that it's growth if my base is greater than 1, and it's decay if my base is between 0 and 1, or if it's a fraction for my base. Okay, now, and remember, there's a value in here that doesn't transform anything, and that's this base right here. This is our base. That's just helping us determine if it's growth or decay. So if you need to pause this and get that down, you can do that before I move. So on my first function here, my base is 2. That's not going to transform anything. But knowing that my base is 2, that tells me that it's growth. So I know that the shape of my graph looks like that, looks like growth versus decay. So up here, let me just quickly give you a reference. This is our basic shape for growth. And here's our basic shape for decay function, okay? Growth versus decay. I know that my graph will have this shape overall. And now what I do is I transform the anchor point. So remember, our anchor point is at 0, 1. And I'm going to read this function like I read a book. So I'm going to always start at the beginning and then kind of work my way through the transformations. The first transformation I see is this a value out front, which I know multiplies everything by 4. If I multiply my anchor point by 4, all of it, okay, it's going to give me 0 times 4, which is 0, and 1 times 4, which is 4. Okay, first transformation. The only other transformation that I have is this x minus 2 in my exponent. This is shifting my graph to the right 2, or it's adding 2 to the x value only. That's 2. Okay, it's an x value change. So let me just go back up to our guidance here. It is an x value only change. So if I have subtract 2 here, I'm adding 2 to just my x value. That's all I have for transformations. Multiply by 4, go to the right 2. Here's my new anchor point. I did not move my horizontal asymptote at all. So what was it that changed our horizontal asymptote? Let's go back to yesterday's notes. The only thing that would change our horizontal asymptote away from being y equals 0 is if I shift up or down. When I shifted up or down, when I changed my y value of my anchor point, my asymptote also changed that many units. Okay, because this first graph does not have an up-down shift, then I know here's my anchor point, and I know that my horizontal asymptote is still at y equals 0. So I'm going to draw in my asymptote first. Just a dashed line, oops, where y equals 0. And then I'm going to draw in my anchor point, and I should clearly see that point on your graph. So 2, 4. I think that's a 4. 1, 2, 3, 4. And then all I'm going to do is draw on a sketch. So I know that it's growth because the base is greater than 1. And then draw in approaching 0, 0, probably a little too curved there, but as best as you can. Draw in a growth curve through that anchor point approaching that asymptote that you've identified. Okay, so for all of these graphs, I should see, is it growth or decay, all the changes to your anchor point, and where's your asymptote. And then on your graph, I should see that asymptote and that anchor point and that overall shape there. Okay, let's look at another one. So next function, again, this 2 is not a multiple out front. This is just our base. So that tells us, because it's 2 greater than 1, that that's a growth graph. Okay. Now I'm going to take my anchor point, start it at 0, 1, and work my way through the transformations. So the first transformation I see is an x value shift, and it's going to be opposite of what we have here. So I'm going to go to the left one, or I'm going to take this x value and I'm going to subtract 1 from it. And now my anchor points moved from 0, 1 to -1, 1. I moved over left 1. The next transformation I see is +3. That's going to go up 3. So my anchor point, what's going to change now is my y value is going to go up 3. So now I'm at -1, 4. -1 doesn't change for that transformation, only the y value changes. I'm gone through my function. Here's my new anchor point. Now, because I had this shift up and down, that's changing. My horizontal asymptote is now going to be at y equals 3. It's about to write 0 again. Okay, my horizontal asymptote is going to be at y equals 3 because I've moved up 3. So I go up 3. Now I'm approaching here. So when I draw on my graph, I should not be crossing that line. If I cross that line, then I don't understand the concept of what that asymptote is. My anchor point is at -1, 4. And I know the shape of my graph is growth. So I'll do the best I can. Drawing that shape in, going through my anchor point, approaching that asymptote. And again, I shouldn't be drawing it in and it's crossing underneath that asymptote. That's going to be an incorrect graph, okay? It's approaching that line y equals 3 through that anchor point and then exponential growth, okay? Okay, let's flip this over. I'm going to choose just, I think, one more to do with you. And I want to do the last one on this page, okay? So first, here's my base. So again, remember that number that's attached to that exponent, that's not doing any transformation, that's your base. Because now I have a value that's less than 1, that tells me that the shape of my graph is decay. But the other thing that I see here is I see a flip. And so anytime I see a flip, I go ahead and I draw that into my shape of my graph. So this negative out front is going to flip it over the x-axis. Flip over the x-axis. Anytime I see a negative either in front of my function or in my exponent, I want to draw what that means for how my graph will look. So I know it's decay because of that base, but it's going to be decay flipped over. If I took that graph and flipped it over the x-axis, which would look, oops, like that, a little bit like that. Taking this function, I'm just flipping it over. So I know my final graph will look like this. So this is important to include in your work as you work to show what this function looks like on the graph. Okay, so start with decay, any flips, do that. Here's what my graph will look like in the end. That's the overall shape. Now let's do anchor point. So starting at 0, 1, starting all the way to the left here, I have -2, which means I'm going to be multiplying by -2. 0 times -2 is 0. 1 times -2 is -2. Then I go, okay, there's no left-right shift. There's nothing happening here, but I do move up 4. And that change is to the y value. I'll add 4, bringing me to here, 0, 2. Now, the other thing that has changed is my horizontal asymptote. Anytime that I have an up-down shift, it moves your asymptote. So now my horizontal asymptote is at y equals 4. 1, 2, 3, 4. There's the line that my graph should be approaching. And I've transformed my anchor point, multiplying by -2, going up 4 for my y value. And I'm at 0, 2. And I know that my decay graph, because it's a decay, exponential decay, has flipped over the x-axis and it will look like this. And again, I can't cross that asymptote and start approaching that line as I get to the other side. Okay. So why don't you try just the first one on this page? Just do the first one and do those transformations. Then try the video, watch the video again, see how you did on the first one. And then I'll let you do the next two. Okay. Okay, so let's look at the details that I have here. My base is 1/2, so it's decay, but there's a negative out front. So I know it's going to flip over the x-axis, and this is the shape I'm going to draw in. My anchor point gets multiplied by -2. And then this shift here is going to go right to or add 2 to my x value. And here's my new anchor point. There was no up-down shift, so my horizontal asymptote stays the same. So I'm still approaching 0. And my new anchor point is at 2, -2. And the shape that I'm drawing in through that point, it's right there. Approaching 0, shouldn't have flared back out there. Approaching 0, but not hitting 0. Okay. Now on the next one, before you start this one, I want to change something about it. Let's get rid of the night. We're not gonna look at x or y axis flips right now. It gets a little more complicated than we're gonna get into this year. So just make that a positive x plus 2. Okay. And then the next one's fine, ready to go. So I want you to now pause the video again and try to complete these next 2 graphs. Again, make sure you're including all the details. What's the shape? How's the anchor point moving? And did the asymptote move at all, or is it still y equals 0? Okay, so hopefully you've done the next few graphs. I'm just going to kind of talk through it as I go. So my base here is 2, which tells me that I have growth. That way, and you can kind of check your work as you go. There's no flips, so I know this is going to be the shape of my graph. For my anchor point, starting at 0, 1, first thing I see is a multiple of 3, which changes it to 0, 3. And I do have to start here, because if I'm multiplying, I can't add and subtract from my x and y and then multiply at the end. I have to start all the way here and work my way across the function. Okay, so multiply by 3. This negative, or this plus 2 is going to make my x value become -2. It's going to subtract 2 from my x value, where it's going to go to the left 2. Okay, x value shift there. This is a y value shift. So for my y value, I'll add 1. I'm going up 1. And I have -2, 4. Here's my new anchor point. I've read the function, multiplied, left x value change, y value change. For my asymptote, because there's a value being added at the end here, that's changing my asymptote to y equals 1. So now instead of approaching 0, my graph should approach this horizontal line where y equals 1. Y equals 1, that -2 4, growth graph, approaching, didn't quite get down far enough, approaching 1, growth, best job you can drawing in a sketch of that function, okay? There's the first one. Second one, again, this value is not a transformation, it's just our base, and that's telling me that it's decay, because it's a value less than 1. I don't see any flips, so this is the shape I'm going to be drawing in. The anchor point. Let's start over here. First, multiply by 2, making that anchor point 0, 2. Now I have an x value change, which is going to go to the right 2. Okay, -2, and my exponent's going to add 2 to the x value, bringing me to 2, 2. So I've multiplied by 2, move to the right 2, and last I need to go up 1. This is a y value shift, giving me a final point at 2, 3. Okay, because I have a up-down shift, it's changing my asymptote to be at y equals 1. I'm approaching y equals 1 now instead of 0. Okay, and what's important is that we don't cross that line. Like if your graph going across that asymptote, you're not understanding that concept of approaching but never crossing. So 2, 3, there's my new anchor point, right in this shape, approaching that line but not crossing it. And there's the sketch of my next exponential function. Okay, and you'll get lots of practice with that today as you do the homework for exponential functions, but it's just a sketch. And so the pieces that I want to see are, how did your anchor point change? And I want to see that point on your graph, like make sure it's clearly identified on your graph. What shape is it going to be? And where's your horizontal asymptote? Okay, those are kind of all the pieces that I should see when I look at homework or the quiz on this in the future.